We are going to look at properties of exponents. Warm up. Can you explain what 4 to the third power means? So 4 to the third power means if you were to take 4 and multiply by itself 4 times. So that leads us to the anatomy of an exponent. So in an exponent that looks like this, the big number, the bottom number, we call the base. And then the little number we call the exponent. All right, so you might see it written in this form, b to the power of x. Your goal today, use what you know about exponents to find patterns and generalize rules to simplify problems with exponents. So we're going to take an investigation where we write something out, and instead of doing that for all, look for shortcuts, and then we'll talk about using those patterns then when we look at exponents. So the first one, we're going to write each product in expanded form. And then we're going to rewrite it in exponential form. So we'll do the first one together in class, and we'll say, all right, 2 to the third, what does that mean? It means 2 times 2 times 2. And 2 to the fourth, what does that mean? 2 times 2 times 2 times 2. How many 2's do we have? So again, this right here that I just wrote, this is the expanded form. And then exponent form, we will look at the base. The base for this is 2. And it's 2 to what power? We have 2 to the 7th power. So we'll do this until we find a pattern, and then we're going to generalize our pattern to write the rule. So the next one, we have 5 squared, 5 times 5, and then 5 to the 6th power. All right, and if we take a look at that, that's the expanded form. And if you write it in exponential form, the base is 5. And if we count how many 5's we have 8. So by then, kids start seeing a pattern. I'll write out one more, and then we'll take a look at C, and looks like C. So we'll take a look at D right here. If we write 7 times 7 to the 4th power, that becomes 7 to the 5th power. So if you look at the rule, how do we take these exponents? How does that factor into our answer? So here the exponent would be 1. How do these exponents factor into our final answer here? And if you take a look, the pattern is if you can add the exponents, then you can write it in an exponential form without expanding it. So let's apply that reasoning to this right here. We would have 7 tens and 2 more tens, and that would give us 10 to the 9th power. So again, if they have the same base, you can add the exponents. How about this one right here? We have x to the 7th and x to the 1st power, so you would have x to the 8th power. So we call this the product rule. When you multiply two things with the same base, such as a and a, you look at the exponents and you're going to add them together. So we have a to the n plus m power. Let's extend. So here we have the base is 12. And if we add the exponents, we get 12 to the 167th power. All right, let's try that when we have division here. So again, we're going to expand it or write it out until we find a pattern. So we have 5 4's on top, and we have 2 4's on bottom. We can cancel the 1's, and so our final answer is 4 to the 3rd power. Over here, we have 8 x's on top. We have 6 x's on bottom. So when we cancel, we have 2 x's left on top. Our last one, we have 9 11's. Well, let's look for a pattern before we do that one. So the question is, how can you take the 5 and the 2 and get the 3? How can you take the 8 and the 6 and get the 2? And the answer is you can subtract them. So if we take 9 minus 3, we will get 11 to the 6th power, because you would cancel 3 from the top and the bottom, and you would have 6 left on the top. So to generalize, when you have the same base and those exponents are being divided, it will be that base to the m minus n power. So extend, if we have base b to the 200 power over base b to the 135th power, if we subtract those, we'll get b to the 65th power. Okay, we got 2 rules left, and then we'll practice some. So rule 3, can you expand and simplify, cancel the 1's? Okay, so now we have 4 5's on top. We have 7 5s on bottom. So when you cancel, you have 3 left on the bottom and you have a 1 on the top. So this is 1 over 5 to the third power. Over here we have 2 x's on top and 6 x's on bottom. Okay, so when we cancel, we have a 1 on top and we have 4 left on the bottom. And for this one, we have 5 x's, 17s on the top and 7 on the bottom. So when you cancel, you have to think how many 17s are left and where are they? There will be 2 of them left on the bottom. Here we have 1 x on top and 4 on the bottom. So when you cancel, you have 3 left on the bottom. So it says rewrite each expression using rule 2, which is subtraction. So rule 2 I'll write in red. If we take 4 minus 7, we get 5 to the negative 3. If we have 2 minus 6, we get x to the negative 4. If we have 5 minus 7, we have 17 to the negative 2. And if we have 1 minus 4, we get x to the negative 3. So if we take a look at that, we can see this last rule, which is if an exponent is positive on the bottom, you can write it negative on the top. So for example, if we have a to the negative n, we can make it positive by flipping it to the opposite side. All right, so I think this one makes more sense when we do some examples. We can rewrite 1 over x, or x to the negative 2 as 1 over x squared. We can rewrite v to the negative 11 as 1 over v to the 11th. If it's 1 over b to the negative 2, we can flip it to the top and it becomes b squared over 1, or just b squared. And for this one, we leave the 3 there, but we flip the y to the 90th on the top. So if it's negative, you flip it to the opposite spot to make it positive. And our last rule, and then we'll do some practice, show why a to the 0 equals 1. Okay. All right, so I'm just going to pick a base. I'll do 5. Let's say we have a to the 5th over a to the 5th. All right, this equals 1 because any number divided by itself is 1. Using the rule that we learned, we can subtract. This would be a to the 5 minus 5, which gives us a to the 0. So we can see why anything to the 0 power is 1 because it comes from dividing any number by itself. So that's our last rule. Anything to the power of 0 is 1. It comes from dividing something by itself. All right, so let's do some examples. We want to rewrite so all exponents are positive. If it's negative, we're going to flip it to the top. So we already have a 5 on the top, but now we flip this one to the top as well. So this is equivalent to 5b to the 13th. Here we have the same base being multiplied. So if we were to write it out, we would have 17 to the 1/44th power. Our next one, we have x to the first power times x to the third, so that's x to the 4th power. Here we have 10 x's on top and 13 on the bottom, so when we cancel, we have 3 left on the bottom. Another way to write that is x to the negative 3 power. So today is just kind of a basic intro to these exponent rules, and tomorrow we'll practice these and formalize a few more.